Afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are talking about systems of linear inequalities. What is a system of linear inequalities? Well, we have one right here. The system is made up of these two inequalities. X plus 3y is less than 5, and 3x minus 2y is greater than negative 2. And these are graphed right here and right here. Now we have graphed individual inequalities, and remember we did the test points and then we shaded above or below. Well, a linear inequality, we do the same thing for two inequalities. We shade, and the solution is what they have in common, the shading area that they have in common. And in this case, it's this light brown area right here. Okay, so everything, every single point in this light brown area where I'm moving the cursor is a solution for the system for both of these inequalities. Okay, so that's just a quick intro. How do we go about solving these? Let's see if I can do that. Okay, so here we go. Graph the following system of inequalities and indicate the solution set. Okay, so I'm going to put both of these in y equals mx plus b form. So I'll do this one in pink. And to solve this one, I'm just going to subtract x from both sides. And that would make this y is less than negative x plus 1. So let's go ahead and graph that one. Okay, so this is in the form of y equals mx plus b. Now there's actually an inequality symbol less than there, but remember, when we graph an inequality, we graph it like we would graph a line, and then we shade to take care of the inequality. Well, m is the slope, so in this case, the slope is equal to negative 1, that's the coefficient of the x term, and the y-intercept is b, which in this case is 1. So to graph the inequality, let's make my scale, 1, 2, 3, 4, 5, there, and then we'll go 1, 2, 3, 4, 5 there. Okay, so 1 is the y-intercept, I'll put a point there, and the slope is negative 1. So that means from here, since it's negative, I go down 1, and then I always move to the right. Remember, you should think of this when it's a whole number as negative 1 over 1. That helps you graph it. So I'm going to go down 1 and to the right 1, and I have my inequality. Now we're going to draw a line through those 2 points, but remember we have to determine whether that line is solid or if it is dashed. In this case, it's dashed because it's just less than. It's not less than or equal to. If it were less than or equal to, which I just put in there, then we would use a solid line. But this one is not, so we're going to have a dashed line. So let me go to my line tool here, make sure that it is dashed, and I said I'd go pink. So I have to sort of eyeball this line here. Let me see how well I can do. I think I've got it right, and hopefully it's going to go through those 2 points. Not bad, okay? So now I'm going to do a test point to do my shading, okay? My test point, and I'm going to use this inequality. I'll use 0, 0, and so my test point is 0 less than 0 plus 1. If I replace x with 0, I get negative 0, which makes no sense. It's just 0 plus 1 is 0 less than 1. Here's my test point right here. 0 is less than 1. So that means all the solution to this inequality all by itself are on the same side as my test point, because when I tested my point, the inequality that we had made sense. Okay? So this is, and I'll label this x plus y less than 1. That was the original inequality right there. So now I'll do this other one in blue, and I'm going to solve it by subtracting x. Well, you know what I'm going to do? No, I'm going to go ahead and subtract x from both sides, minus x. So that gives me, let's see, negative y is less than negative x plus the 5. And I need to get rid of the negative in front of the y, so I'm going to divide both sides by negative 1. I don't know why that's little horizontal thing is there, so I have to divide everything by negative 1. And when you multiply or divide an inequality by a negative number, then you have to change the inequality. So this is going to change from less than to greater than. So y is greater than a negative x over negative 1 is a positive x, and a positive 5 over a negative 1 is a negative 5. So my slope for this one is 1 over 1 because the coefficient of the x term is 1, and my y-intercept is negative 5. Okay, so I'm going to go down to negative 5, 1, 2, 3, 4, 5, right there. And my slope is positive 1 over 1, so that means I'm going to go up 1 and right 1. Okay, and then I'm going to draw my line through those 2 points. Okay, and then again I have to see, is my line solid or is it dashed? And it's dashed because it's just greater than, it's not greater than or equal to. There is no equal to symbol here, so that means it's dashed. So I'm going to go back to my line. Let's see, I already have it dashed. Let's make it blue to be consistent. And let's see how I can do here. Okay, I'll start it here and see how I do. See if it goes through those 2 points. Not bad at all. Okay. Now, for now, you have to ignore all the pink, and we're just graphing the blue here. And so I'm going to use 0, 0 as my test point. This is my blue test point right there. Is 0 greater than 0 minus 5? So is 0 greater than negative 5? And the answer is yes. So that means I'm going to shade all points on the same side as my test point there. Okay, so everything here is part of the solution to this particular inequality. But the solution to the system is where these shadings intersect, where the shading is common, and that's right in this area right here. So I could leave it because it's all crossed, but just to make sure that we understand, I'm just going to shade it a little darker through here with all of this so we understand that any point in here is a solution to the inequality. Okay? So what we could test a point here, like, I don't know, like negative 6, 2 is let's see, what, about right here? Can't really see it, but negative 6, 2 should satisfy this. So is negative 6 plus 2 less than 1? Negative 4 is less than 1, so it works. So here, let's plug it into the original equation. Negative 6 minus 2, negative 6, 2 was our point. Is that less than 5? Is negative 8 less than 5? It is, so we know that we are correct. Okay, so that's the one example I wanted to give you. I'm going to give you a couple of homework exercises and we'll move on from there. See you next time.